Hi everyone. Today we are going to study about projectile motion, which is one of the most interesting topics in physics because you can learn about projectiles such as, say, a football. So when you kick a football, how long it will go, how long it will stay in the air, how high it will go, all of these questions can be answered by understanding projectile motion. So let's move forward. First, what is projectile motion? Projectile is any object launched into the air and moving only under the influence of gravity. So, say for example, when you kick a football in the air, or you shoot an arrow from a bow, water coming from mountain, stones thrown horizontally. All of these are projectiles. The only thing that we need to remember is that there is no force acting on the projectile other than the gravity. So, one big thing to understand over here is for a projectile, there are actually two independent motions happening simultaneously. One is constant horizontal velocity. And of course, here we are ignoring the air friction. So, horizontal velocity of the projectile is constant. Now, the vertical velocity is, of course, under the influence of g, which is under the influence of gravity. So we can treat it as two separate motions. One horizontal with constant velocity with no force acting on it. The other one is vertical with g force acting on it. Keeping these two things in mind, we'll move to the next slide. Now you can look at the beautiful parabola over here, right? The motion which is performed by a projectile, it forms a parabolic path. So from the picture, it is clear the range is something which is from where the projectile starts to where it ends. The distance between the 2 points we call range, which is denoted by r. The maximum height up to which it goes, we denote it by h. The angle at which it is launched, that is called theta. And one more thing to notice over here is that, see, at the maximum point, h, only the horizontal velocity remains. Vx is the only component of velocity that remains. The vertical velocity becomes zero. From where it flips, starts coming down, right? Now let's look into some equations for the same. Now, let's say the initial speed is u and the angle at which we launch, it's called, let's say, to be theta. And g is always 9.8 meter per second square that we are already aware, right? The initial components of the speed would be the vertical component and horizontal component, and we can treat them separately as discussed before. So ux, which is u cos theta, horizontal, it remains constant throughout, and uy, which is u sin theta, which is the vertical velocity, which changes according to g force that is applied on the projectile. Now position. See, the horizontal position, since the horizontal velocity is constant, so it's nothing but velocity into time, which is u cos theta into t. The vertical velocity, now from the kinematics equation, which is s equal to ut minus half at square, at square, that will be applied over here, right? Because the g force is pulling it down. So you can replace u with u sin theta because vertical velocity is just u sin theta and acceleration a is g over here. So position y becomes u sin theta into t minus half gt squared. Now the maximum height, which is h, that is equal to u square sin square theta upon 2g. This we have just obtained by keeping our vertical velocity to be zero, right? Time of flight, p equal to 2u sin theta by g. It is nothing but double the time it takes for the projectile to reach at the top. Range is u square sin 2 theta by g. Now here, maximum range is when 2 theta is equal to 90 degrees. then theta should be equal to 90 by 2, 45 degrees. So this is something that we should remember. Now we'll solve an example. A ball is kicked at 20 meters per second at an angle of 30 degree with the ground. We have to find its height, time to flight, and range. So u is 20 meter per second, theta is 30 degrees, and our force g. For this problem, we can take it 10 meters per second square for simplification of our equation. So max height, as discussed, u square sine square theta. Now you put the value of u as 20, theta as 30 degrees, and g as 10 meters per second square, and you get height as 5 meters. Similarly, you have to use the equations for time of flight and range, and you get the results over there as well. Now, before I end my class, I want to give you like these 5 key takeaways for this particular topic. One, as we already discussed, horizontal and vertical motions can be completely different from each other. Horizontal velocity stays constant throughout the flight because there is no horizontal force acting on it. Here, we are assuming that there is no air resistance. Vertical velocity changes only due to the force of gravity, and it becomes zero at the highest point because there it flips, right? Range is maximum when theta is equal to 45 degrees. Complementary angles, 30 degrees, 60 degrees, give the same range. This is also something that we should note. Path of the projectile is always parabola. Again, this also keeps the assumption in mind that air resistance is ignored over here. Now, what we can do is basically solve a few more problems in this manner and recall these 3-4 points. Basically, the formula for h, t, which is time it takes for the projectile to come down to the ground, and r, which is the range. And maximum range comes when theta is equal to 45 degrees. Path is always parabola. So that's the end of the class. Thank you.